All right, so today we're going to solve exponential and logarithmic equations. We're going to actually spend 2 days doing that. The ones we do today will be situations when there is only one exponential expression or one logarithmic equation. And then tomorrow we'll move to ones that are a little bit more complicated where there's multiple. We'll have to use the properties of logarithms to solve it. So we won't really use a lot of properties today. So the main thing you need to be able to do today is go back and forth from exponential form to logarithmic form or logarithmic to exponential form. And so the first step is to isolate the exponential expression or logarithmic expression on one side of the equation. So that's just using algebra. It's addition or subtraction or division or multiplication. All right. The next step is to rewrite the equation in the alternate form. So if it is an exponential equation, then you have to use logarithms to solve it. If it's a logarithmic equation, then you have to use exponential or exponents, I guess, to solve it. All right, and then solve for the variable if necessary. And then we're going to simplify or round. Now we are not going to use the calculator today, so we won't be doing any rounding. The majority of this type of question is going to be on the non-calculator part of your test. So I don't think they're going to put a lot of equations on the calculator part because you can use your calculator, like use the answer choices to solve. So I think this is mainly going to be non-calculator stuff. Okay, and so for example 1a, this is the exponential expression. And so we're just going to use good old algebra to isolate this or to get this by itself. So what would you guys do? You would just add 2, good. So 4 to the x equals 9. Now, 9 is not like an exact power of 4. We could kind of guess about what x would be. But to solve for x, the exact form of x is now that this is isolated, it's in exponential form, we're going to write it in logarithmic form. So when we write in logarithmic form, we start with the word log. Hey, Willoughby, put your phone up, please. And then what would the base be? 4. And then we would write the argument, which is 9. And then that's going to equal x. So some of you I know in Algebra 2 like to do the loop. You can do the loop if you want to. If you don't need it, it's fine. And then that's what x is. X is log base 4 of 9. So if I had that as my exponent, then it would just give me 9. Oh. Okay, let's look at the next one. It has a few more steps. So at the beginning, same thing. This is my exponential expression. Bless you. I want to get it alone, so I'm just going to subtract that 5. That's not something we can figure out in our head. Like 2 to some power gives you 21 because it's not an exact power of 2. So we can write this in logarithmic form. Log base 2 of 21 should equal the x plus 3. All right, and then to solve it, I would just subtract that 3. Now because I'm going to write something after the 21. I'm going to put the 21 in parentheses. And then I can't actually subtract that 3 from 21 because this is kind of like locked together, log base 2 of 21. That 21 can't change unless I use some kind of properties of logarithms, which I'm not. So that would be my answer for x. All right, and then this last one. Before I write it in logarithmic form, I am going to get e to the x alone. So I'm going to subtract 3. And then divide by negative 4. All right, and then you guys go ahead and write this in logarithmic form, please. All right, so if e is the base, then what logarithm do we use? Good. The natural log of 5/2 is equal to x, and that's you're done. You're done. X is that. All right. Any questions? All right, and so the next couple of examples, they are extra challenging exponential functions. We still technically 3 to the x kinda is our only exponential expression. So I included it with today's instead of tomorrow's assignment, but it's a little bit different. And so this is like a trinomial. So we're going to solve it like we would have solved x squared minus 2x minus 24 equals 0. It's going to feel weird, but we can do it. All right, so we're going to go ahead and just factor this. So if we were actually factoring the polynomial that I wrote, here and here, I would put x, so I could multiply and get x squared. But what I put here and here needs to multiply to get 3 to the 2x. So what do you think it needs to be? They're going to be the same thing, that when I multiply them, I get 3 to the 2x. Absolutely. I'm going to show you why, so go ahead and write it down. All right, so if I multiply those two together, I would get 3 to the x times 3 to the x. Would the 3 change if I multiplied it? No, it would stay 3, and then what would you do with the exponents? You would add. And when you add, you get 3 to the 2x. So that is right. That is what I need to put there. So when I multiply it, I get this. All right? And then to figure out if your signs are positives or negatives, you look here, which is the same place as here. So if that's a minus, do you guys remember what it would be? 1 plus and 1 minus. Okay, and then just like before, what I put here and here needs to multiply to give me the negative 24. And then since the signs are different, technically subtract to give me that negative 2. So what do y'all think? Yes. And then the 6 would need to be negative, so I would get the negative 2. All right, now I'm just going to go over to the side and show you that this does work. You don't have to write it out. But to get that negative 2, 3 to the x, that's when you would multiply these together and combine your like terms. So when I do this outside, that's negative 6 times 3 to the x. And then when I do this inside, it's 4 times 3 to the x. So then when I combine those, you just add the numbers that are in the front, and that's where you get the negative 2. All right, so thinking back to polynomials, it's been a while since we talked about polynomials. What do you do? Like, we're solving this by factoring. What do you do after you factor?
Separate the...
It's okay. You set them each equal to 0. Good. Okay, and then we have two little equations like I had on example 1. So I would get the 3 to the x by itself. Now this is a unique situation, kind of. Is there a power that you can raise 3 to and ever get negative? There isn't. Like some people would say a negative exponent. Does a negative exponent make it negative? It makes it a fraction. Very good. So this is not possible, and that's fine. It's okay. The other one, though, I would add that 6. And then just like I did on example 1, I would write this in logarithmic form. And that's going to be my answer. So this one only has one answer. So it's possible you could have 2 solutions. It's possible you could have no solution, but if you ever have a positive base raised to power equals a negative number, there's no way that can happen. All right, so let's think back to solving polynomial equations by factoring. What did you have to have on one side to be able to do it? You had to have 0. And so if you don't have 0, it won't work. But it's really easy to make it be 0. So I'm just going to move that 15 over so I can get everything on one side. And then I'm going to factor it like it's a polynomial. Even though it isn't, you can still use those methods. Okay, and so what I put here and here needs to give me e to the 2x. Good. Right, and then this tells me my signs are plus minus again. All right, you guys finish it from here, please. So we should just get one answer, and it should be the natural log of 3. Okay, so that's how you solve exponential equations when you have a situation where you're going to factor, and then, or you just have a basic exponential equation. You have to use logarithms to solve. It's the only way you can get the exponent down or get the x down from the exponent is to use logarithms. Okay, then the last 3 we're going to do are going to be logarithmic equations, and the only way we can solve those is to use the exponents. And so, same beginning step, isolate the logarithmic expression. And so this is the logarithmic expression.
Including the 2?
Not including the 2. All right, so just using algebra, we would subtract that 4. Right, and then divide by that 2. All right, at this point, this problem has way too many 3's in it, but that's okay. It'll be fine. All right, so once you get the logarithmic expression isolated, then you're going to do that second step where you're going to rewrite it in the alternate form. So the alternate form this time is going to be exponential form. And so this 3 is the base of the exponent. And then this 3 is the exponent. And it should equal the the argument. So if you guys like to do the loop, same thing. All right, and then from here, this is just going to be a fairly simple equation to solve. So do you guys know what 3 to the 3rd is?
27.
Yeah. If you don't, it is something that you are expected to be able to do without a calculator, so you just have to just multiply 3 by itself 3 times. And then to finish this off, we would just subtract 3. And so x is 24. So if I took the 24 and I put it in for this x and did all the stuff, I should end up with 10. And that is something we are going to do tomorrow's lesson. We have to check our answers on all the logarithmic equations. On these simpler ones, we actually don't really have to worry about that. Okay, so let's look at B. The logarithmic expression is this whole thing right here. So So all we have to do to isolate it is just subtract that 2. Then we can write it in exponential form. And then take a couple of steps and solve it for x. So I should be able to take the 3, put it there, do all the stuff, and end up with 4. Okay, one last example. You guys want to try to do this one on your own? Okay. You, just a heads up, you cannot get an answer just like 3 or 24 on this one. You'll get an expression as your answer. You could also have written this, just depending on the order you did the solving, is also could be negative e to the 5th plus 2. Those are the same answers. All right, what questions do you guys have? Okay, so tomorrow we'll have to review some of those logarithmic properties. Well, you guys did pretty well on your quiz.